So hello everyone. Before moving to the next part, let's solve this question first. So in this question we have given that in a vacuum tube, electrons are emitted from a hot plane metal surface, emitted and collected by another metal plate collector placed parallel to the emitter at a distance d away. So this is emitter plate and this is collector plate, and the distance between them is d. The distance d is small compared to the dimensions of the plate. The electric potential between the plate is given by this. So electric potential between the plates is given by V of x is equal to Cx to the power 4 by 3, where x is the distance from the emitter plate and C is a constant. What is the surface charge density sigma on the emitter plate and collector plate? So we have to calculate what is the sigma here and what is the sigma here. Sigma E and sigma emitter and sigma collector. And what is the volume charge density rho v in the region, the two plate. So we have to calculate rho v as a function of x also, and we have to plot the density as a function of x. So how can we calculate sigma first? Let's solve. So in this question we have given that there is an emitter plate and there is a collector plate, and the distance between them is d. So let's assume that our coordinate axis, here we have x equals to 0 and here we have x equals to d. So we have given that V of x is equals to Cx to the power 4 by 3. So what is the potential at here? Potential here, that is V of x equals to 0, that is equals to 0. And what is the potential here? That is V of x equals to d, which is equals to C d to the power 4 by 3. Now how can we calculate sigma? Sigma is related as, we know that electric field in this region. So electric field in this region is equals to sigma by epsilon naught. So if we know the electric field in this region, we can easily calculate sigma. So let's calculate electric field. And we have seen in the last part that electric field is equals to minus gradient of V. So which is equals to minus gradient of Cx to the power 4 by 3, which is equals to minus 4 by 3 C into x to the power 1 by 3 x cap. So what is electric field at x equals to 0? At x equals to 0, electric field is equals to 0. At x equals to d, electric field is equals to minus 4c by 3 d to the power 1 by 3. So what is this? What is the value of sigma at x equals to 0? Sigma at emitter, which is equals to sigma E, it is equals to 0, because sigma equals to epsilon naught times electric field. And what is the sigma at? What is the sigma at x equals to d? So that is equals to minus 4c by 3 epsilon naught d to the power 1 by 3. So this is sigma collector. Now let's move on to the second part. We have to calculate rho v. How can we calculate rho v? We can calculate rho v by this relation, del dot E is equals to rho by epsilon naught. This is the differential form of Gauss law. So del dot minus 4c by 3, what is electric field? Minus 4c by 3 x to the power 1 by 3 x cap. It is equals to rho by epsilon naught. So from here we can say that it is equals to minus 4c by 3 into 1 by 3 into x to the power minus 2 by 3 equals to rho by epsilon naught. So from here we can say that rho as a function of x is equals to minus 4c by 9 x to the power minus 2 by 3 into epsilon naught. So this is rho of x. Now we have to plot this also. So we have x equals to 0 and x equals to d. At x equals to 0, it is going to tends to minus infinity, and at x equals to d, we have rho of x equals to d is equals to minus 4c by 3 epsilon naught d to the power minus 2 by 3. So this value is equals to minus 4c by 3 epsilon naught d to the power minus 2 by 3. So this is rho of x as a function of x. Let's solve this problem.